Good evening, students. Hello, good evening, students. लास्ट लेक्चर में हम लोगों ने गियरिंग गियर्स टॉपिक स्टार्ट किया था, जिसमें हमने बेसिक चीजें डिस्कस की थी। एक बार रिवाइज कर देता हूं मैं वो। फर्स्ट, जो टॉपिक लास्ट लेक्चर में हमने डिस्कस किए थे वो था, पहले फर्स्ट ऑफ ऑल, व्हाट इज गियर्स। गियर्स आर यूज्ड फॉर ट्रांसमिटिंग द पावर्स। ओके, बेसिक एडवांटेजेस ऑफ द गियर्स आर the it transmit exact velocity ratio. First advantage of the gears are. Second advantage of the gears are, it transmit large powers. It can transmit large powers, and the efficiency of the gears are high comparatively to other power transmission systems like pulleys, chains, sorry, belts and chains, etc. The reliable, the gears are reliable, and the layout of the gears are very compact. The gears are manufactured by special tools and equipments. The manufacturing of the gears are very difficult. Second, if the teeth of the gears are not designed, manufactured properly, in that case, vibrations and noise are developed. Second, the classification of the gears according to the position of the axis of the shaft. Gears are classified as parallel, intersecting, and and non-intersecting tools. Okay, classifications of according to the position of the axis of tools: parallel, intersecting, and non-intersecting and non-parallel. Okay, here the shaft of the gears are parallel to each other. In helical gears, the shaft in helical gear also in helical gears, the shaft of the gears are parallel to each other. Helical gears are two types: single helical gear and double helical gears. Double helical gears are also known as herringbone gears. Okay. Next are next non-parallel and non-intersecting gears. Bevel gears are non-parallel gears. Their shafts are not parallel to each other. Gears also classified according to the peripheral velocity of the gears. Depends upon the velocity of the gears. Gears are low velocity gears, medium velocity gears, and high velocity gear. Velocity of the gear, peripheral velocity of the gear less than 3 meter per second are known as low velocity gears. Velocity of the gear between 3 meter per second to the 15 meter per second are known as medium velocity gears. And velocity more than 15 meter per second are known as high velocity gears. Okay. According to the gearing, gears are classified by three types: external gearing, internal gearing, and rack and pinion system. In external gearing, teeth are cut at the external surface of the gear and the meshes externally. But in the internal meshing gears, they cut teeth are cut meshes internally. Here, in that case, gears are meshes externally because teeth are in on external surfaces. Here, on the uh, larger gear, teeth are cut internally, and the the diameter of the gear, which is smaller than the outer gear, is having the teeth externally. So here the teeth meshes inside the larger diameter gear. So this type of gearing is known as internal gearing. In rack and pinion gearing, on a straight bar, teeth are cuts. Okay, this straight bar is known as rack, and a circular gear is meshes with these teeth. Whenever racks moves in left or right direction, according to that the pinion rotates in clockwise or anti-clockwise direction. According to the position of the teeth on the gear surface, uh, gears are classified as straight gear, inclined gear, and curved gear. So in the spur gear especially, teeth are cut straight. In helical gear, teeth are cut in incline, and in other gears, the teeth of the gears are curved, either is cycloidal curve or in involute curve. We will discuss about these curves, okay, involute curve and cycloidal curve, how the cycloidal teeth and involute teeth are designed. After that, some terms are used, which some important terms used in the gears. We discussed about that in last lecture, like pitch circle diameter, pitch point, pitch surface, pressure angle or angle of obliquity, addendum circle, circular pitch, diametral pitch, module, clearance, total depth, working depth, tooth thickness, tooth space, backlash, face of tooth, flank of tooth, top length, face width, profile, fillet radius, path of contact. Path of contact, length of path of contact, arc of approach, arc of recess. ये अभी हम डिस्कस करेंगे. Length of path of contact or path of, what is path of contact? It is the path traced by the point of contact of two teeth from the beginning to the end of the engagement. देखिए इस डायग्राम में फर्स्ट एंगेजमेंट पॉइंट की अगर हम बात करें, then in that case टॉप फेस जो है आपके गियर की टीथ का, वो डिडेंडम सर्किल के पॉइंट को या क्लियरेंस सर्किल को टच करेगा। ओके, और फर्स्ट पॉइंट ऑफ कांटेक्ट के बाद एक स्ट्रेट लाइन के अलोंग ये पॉइंट ट्रेस किया जा सकता है। इसके बारे में हम डिस्कस करते हैं डिटेल में कि पाथ ऑफ कांटेक्ट, लेंथ ऑफ पाथ ऑफ कांटेक्ट, ये सब क्या है, क्या किस तरीके से इसे मेजर करते हैं। सो लेंथ ऑफ पाथ ऑफ कांटेक्ट, length of path of contact, ओके। लेंथ ऑफ पाथ ऑफ कांटेक्ट, ये मान लेते हैं पिनियन है और ये है हमारा व्हील। ये पिनियन का डिडेंडम सर्किल है, ये पिच सर्किल है और ये एडेंडम सर्किल है। इसी तरह व्हील का ये डिडेंडम सर्किल है, पिच सर्किल है और एडेंडम सर्किल है। दोनों व्हील और पिनियन के जो पिच सर्किल्स होंगे वो एक दूसरे से टेंजेंट होंगे, ठीक है, एक दूसरे से टेंजेंट होंगे। तो फर्स्ट जो कांटेक्ट पॉइंट होगा वो कुछ इस तरह से होगा, ठीक है। दिस इज द फर्स्ट पॉइंट ऑफ कांटेक्ट and this is the disengagement of the teeth. This is the first point of engagement of the teeth and disengagement of the teeth. Line A to B, this is the uh, path of contact. A to B is the length of path of contact and this is path of contact. अब इस पे हमें यहाँ पर इसकी वैल्यू निकालनी है, लेंथ ऑफ पाथ ऑफ कॉन्टैक्ट का फार्मूला इक्वेशन हमें फाइंड आउट करना है. व्हेन द पिनियन रोटेट्स इन क्लॉकवाइज डायरेक्शन, ये क्लॉकवाइज डायरेक्शन में रोटेट है हमारा पिनियन, ठीक है. द कॉन्टैक्ट बिटवीन ए पेयर ऑफ इनवॉल्यूट बिगिंस at point A, okay, on the flank near the base circle of the pinion, पिनियन के बेस सर्किल के पास, ओके. Of pinion or the outer end of the tooth face on the wheel and ends at the point B. B point पर ये end हो जाएगा. AB is the common normal, the point of contact and the common tangent to the base circles. ये जो आपका हमारा जो ये पाथ ऑफ कांटेक्ट है, ये जो पाथ ऑफ कांटेक्ट है दोनों के बेस सर्किल पर टेंजेंट अगर हम ड्रॉ करेंगे तो उसके लॉन्ग स्टार्ट होगा, ठीक है. द पॉइंट A is the intersection of the addendum circle of the uh, wheel and common tangent, ओके. बेस सर्किल से टेंजेंट ड्रॉ करेंगे अगर, तो बेस टेंजेंट और अडेंडम सर्किल जो व्हील का है वो जहां पर कट कर रहा है वो ए पॉइंट है. द पॉइंट बी इज द इंटरसेक्शन ऑफ द अडेंडम सर्किल ऑफ द पिनियन एंड कॉमन टेंजेंट. हाँ देखते हैं फिर से. फर्स्ट ऑफ ऑल बेस सर्किल, पिच सर्किल, this is the addendum circle, okay. This is the addendum circle of the pinion, this is the pitch circle, base circle, pitch circle, and addendum circle. This is the addendum circle, pitch circle, and base circle. Common tangents of base circle cuts. This is the addendum of pinion, and this is the addendum of wheel. This is the point A and this is the point B. पहला पॉइंट ऑफ एंगेजमेंट स्टार्ट होगा पॉइंट ए पर अगर पिनियन क्लॉकवाइज रोटेट हो रहा है, और डिसएंगेजमेंट होगा पॉइंट बी पर. ए टू बी इज द पाथ ऑफ कॉन्टैक्ट. ओके, जिसकी वैल्यू हमें फाइंड आउट करनी है, लेंथ हमें फाइंड आउट करनी है. लेट आर ए इज द radius of addendum circle of pinion. Radius of R is the radius of addendum circle of the pinion. ये हमारा आर ए है. अगर इसका मैं लेआउट बनाऊं, देखिए स्ट्रेट, ये हमारे पास स्ट्रेट लाइन है, ये है हमारे पास आर ए O2 O1. Okay, this is the pitch point P. Clear? ये पिनियन का एडेंडम है, रेडियस है पिनियन की, एडेंडम की, और ये आर है. ओके, स्मॉल आर इज द पिच सर्किल रेडियस ऑफ पिनियन. ये पिनियन का पिच सर्किल रेडियस है और ये व्हील का. ठीक है, प्रेशर एंगल फाई है सब में, दोनों में. सो द प्रेशर एंगल विल बी, जो कॉमन टेंजेंट होती है पिच सर्किल की और जो बेस सर्किल से टेंजेंट होता है उसके बीच के एंगल को फाई बोलते हैं. यहाँ पर अगर मैं इस तरह से ये ड्रॉ करूं तो ये एंगल फाई होना चाहिए. ओके, दिस इज द 90 डिग्री एंगल. So this angle will be phi. Okay, ये एंगल फाई होगा, यहाँ पर ये भी एंगल फाई होगा. ठीक है, इस डायग्राम से हम समझ सकते हैं. देखिए, पॉइंट डी, पॉइंट सी, यहाँ पर सी डी पाथ ऑफ कॉन्टैक्ट है जिसे हमें डिटरमाइन करना है. ये पॉइंट एफ को जहां हमने मिलाया है बी पॉइंट से, ये आपका फाई एंगल होगा, प्रेशर एंगल होगा। आर ए पिनियन की एडेंडम सर्किल की रेडियस है, और यहाँ पर व्हील का एडेंडम रेडियस आर ए है, कैपिटल आर ए है। व्हील के पिच सर्किल की रेडियस कैपिटल आर है, पिनियन के पिच सर्किल की रेडियस स्मॉल आर है। ये पिच पॉइंट है पी। हमने यहाँ पॉइंट बी को पॉइंट सी से मिलाया, पॉइंट डी को पॉइंट ए से मिलाया, ठीक है। ये टेंजेंट पॉइंट है, यहाँ पर ये टेंजेंट पॉइंट है और ये टेंजेंट पॉइंट है। बेस सर्किल से टेंजेंट पॉइंट्स हैं, और ये आपके पॉइंट ऑफ एंगेजमेंट और पॉइंट ऑफ डिसएंगेजमेंट। वैल्यू फाइंड आउट करनी है सी टू डी। ओके, here path of contact will be is equal to CD, or it can be written as CD will be is equal to the PD plus PC. PD, P to D can be written as PE minus PD minus ED minus या DE minus PE, and PC can be written as CF minus PF, CF minus PF. Okay, this is the equation number 1. Now, from the right angle triangle AED, AD is RA, here this angle is phi, this is not the phi, this angle is phi. Now from the right angle triangle AEP, AE will be equal to the, or say cos phi is equal to the AP upon AE upon AP, or say AE is equal to AP cos phi, which is AP is equal to R, radius of the pinion, pitch circle radius of the pinion. So it will be R cos phi. Okay. Now from the right angle triangle, from right angle triangle AED, DE square will be equal to the AD square minus AE square. DE is equal to the under root. What is AD? AD is the radius of addendum circle RA. A is R cos phi. This will be the DE, and we have the value of we can determine the value of PE. Okay. DE is equal to the under root RA square minus R cos phi square. So from here, from right angle triangle AEP, sin phi is equal to the PE upon AP, or say PE is equal to the AP sin phi, or PE will be is equal to the R sin phi. Okay. Now from here, path of recess, जो कि जिसकी वैल्यू है हमारे पास यहाँ पे PD, P to D distance is known as path of recess, is equal to the PE minus DE minus PE. So PD will be equal to the under root RA square minus R cos phi square minus R sin phi. This will be the path of recess. Now path of approach. The path of approach will be equal to the path of approach is equal to the C to P. Okay. From right angle triangle BFP, cos phi is equal to the BF upon PB, or B to F is equal to the PB cos phi. PB is the radius of pitch circle of wheel. So P to F is equal to R cos phi, and sin phi is equal to the Pf upon Pb implies Pf is equal to the Pb sin phi. Pb is capital R, so Pf will be Pf is R sin phi. Okay, clear? Now from the right angle triangle, BFP, BFC, okay, FC will be is equal to the under root BC square minus BF square. FC will be is equal to the BC is radius of addendum circle of the wheel minus R cos phi. So the path of approach will be equal to the PC is equal to the FC minus FP. So PC will be under root RA square minus R cos phi square minus FP is F2P is R sin phi. Okay. So total path of contact will be path of approach plus path of recess. So path of approach is under root RA square minus R cos phi square minus R sin phi, and path of recess is under root RA square minus R cos phi minus R sin phi. This is the total path of contact. Now come to the length of contact, length of arc of contact, length of arc of contact. Length of arc of contact will be equal to the length of arc of contact will be equal to the length of path of contact divided by cos phi. Okay. एक सिंपल न्यूमेरिकल सॉल्व कर लेते हैं हम इस टॉपिक पे। The number of teeth on each of the two equal spur gears in mesh are 40. The teeth have 20-degree involute profile. The number of teeth on each of the two equal spur gears in mesh are 40. The teeth have 20-degree involute profile. And module is 6 mm. If the arc of contact is 1.75 meters, 1.75 times the circular pitch, find the addendum. The number of teeth on each of the two equal spur gears in mesh are 40. The teeth have 20-degree involute profile and the module is 6 mm. If the arc of contact is 1.75 times of the circular pitch, find the addendum. What is circular pitch? Circular pitch is length of circular pitch is equal to the pi d by t. Okay, this is the circular pitch. Given data. Number of teeth on wheel and pinion are equal, which is 40. Pressure angle is 20 degree and the module of the gears are 6 mm. We know that circular pitch, we know that circular pitch is equal to the pi d by t, or say pi into module. So circular pitch will be equal to the pi into 6, 18.85 mm. Clear? We know that length of arc of contact is equal to the 1.75 times of circular pitch. So it will be equal to the 1.75 and circular pitch is 18.85 mm. So the length of arc of contact will be 33 mm. Clear? And path of contact and length of path of contact will be equal to the length of arc of contact into cos phi. So the length of path of contact will be equal to the 33 into cos 20. So the length of path of contact will be 31 mm. Okay. Let Ra and small ra is the radius of addendum circles. We know that pitch circle radius will be is equal to capital R, small r will be mt by 2. Okay, here module is 6, number of teeth is 40, divided by 2, it will be equal to the 120 mm. Okay, radius of the pinion and the wheel are 120 mm. Length of path of contact will be equal to the under root Ra square minus R square cos square phi plus under root Ra square minus R square cos square phi minus R plus R sin phi. Okay, path of contact is 31 mm. The addendum and pitch circle radius are same for wheel and pinion, so it will be equal to the 2 into Ra square minus R square cos square phi minus R sin phi, or say 31 by 2 is equal to the under root Ra square minus 120 square cos square 20 minus 120 sin 1 sin 20 degree. So from here Ra will be is equal to the 126.12 mm. So the addendum of the wheel will be equal to the radius of addendum circle minus radius of pitch circle. 126.112 is the 12 is the radius of addendum circle and pitch circle radius is 120 mm. So the final addendum will be equal to the 6.12 mm. Okay. Thank you very much.